In this video, I'd like to present a lesson about circular motion in a way that you and I cannot experience it. But this is a concept that has a very important role to play in any plans that humans have to live in space for extended periods of time. Have you ever noticed that in most movies and TV shows that are set in space, there is artificial gravity? People just sit and stand and walk around like they're on Earth, because they are. They're actors, and the story is about them doing cool things in space, but it sure is easier to film this on Earth by pretending there's gravity inside the spaceship. In fact, they pretend there is gravity inside the spaceship, and then just outside the ship, for some reason, there's no gravity, and also you move in slow motion, I guess? Generally speaking, movie makers and TV show producers just don't explain this stuff. It's inconvenient to get into how they could have strong gravity when they're not actually on a planet. Having some kind of artificial gravity is just a magical part of the setting, like many other parts of these stories, because who cares how it happens?
I care.
I care because these stories, as entertaining as they are, perpetuate some misconceptions about being in space, and I want us to have a better understanding. I'm not trying to ruin your movies, I promise. Let's start by talking about how you would actually show people in space being weightless. Some shows and movies use wire work to simulate that, like you see here. They do this in The Expanse, and that's actually what Adam is working on in this clip. He's on set for the TV show The Expanse. Other movies, like Apollo 13, actually film scenes while in free fall. How do they do that?
But the biggest challenge for the cast and crew was filming in a completely weightless environment using NASA's specially modified airplane, the KC-135.
Move the camera a little over, Tom. Lift them higher, Bill. Bruce, can you widen your shot a little? Level off.
When you're weightless, it feels like you've just been spun upside down. All the blood goes into your head, and it feels like when you're in a Rocco plane in the amusement park, it just feels like that you just got spun upside down. You think suddenly, you think, hey, I'm upside down. No, I'm not. What's wrong? Why is it different? Oh, I'm floating. And then you realize, well, I guess this is weightlessness.
If you would like to see a good video explanation of how exactly they were able to do that, you could check out this video by Diane Cowan, the Physics Girl YouTube channel, which I will leave linked in a slide that looks just like this in our notes. The basic idea is that an airplane can follow the path of a projectile, and you inside the plane will actually be a projectile just inside the plane, which means for a short period of time while the plane is following that projectile path, all passengers in the plane are experiencing basically zero gravity. They are definitely experiencing gravity, but they are not experiencing a normal force from the plane, so they feel like there's no gravity. Again, Diane's video explains it really well. I recommend it. In fact, I also recommend this music video by the band OK Go, and after you watch it, you should check out the behind the scenes where they describe using a plane like the one that Diane used, and which they used in filming Apollo 13, and which really is designed for training astronauts to be in zero gravity in the first place. That's why these exist, not just to make entertaining videos. Of course, in reality, you can get plenty of video clips about astronauts being weightless. Some of them are very entertaining. And many of them are very educational, because NASA and the European Space Agency and the Russian Space Agency really like to encourage astronauts and cosmonauts to be involved in education outreach. They love to talk about weightlessness and what it's like to live on the International Space Station for months at a time without the normal force ever pushing up on you. But right now, I'd like to talk about the physics of spaceflight without weightlessness. That's the point of this video. Being weightless for extended periods is not the best thing for your body. Bone and muscle weakness and bone and muscle loss, along with other physiological issues, can become a real problem, especially over the long term. There are two ways to deal with this. One is thrust gravity, which is a cool idea, but it requires a constant fuel source, and then it runs out. Until the fuel source runs out, thrust gravity works this way. If you are inside a rocket and the rocket is accelerating upward, then you experience that acceleration with the rocket. I shouldn't even say accelerating upward, because what does up mean? If you are in the rocket and the rocket is accelerating because of the engines that we can see at the bottom of the screen, then the rocket would be accelerating toward what we consider the top of the screen. And a person in the rocket, if you were to draw a free body diagram of what they're experiencing, you would see only that they are being pushed toward the top of our screen. If the rocket's acceleration were 9.8 meters per second, then the person in that situation would experience, they would feel physically the exact same thing that I feel when I'm standing out in the middle of the room and the floor seems to be pushing up on me and the gravitational field is 9.8 newtons per kilogram. There is no way that I could tell the difference standing in that rocket. If there were no windows or anything like that, I couldn't tell the difference between accelerating in a straight line at 9.8 meters per second and standing in the Earth's gravitational field at the surface of the planet. So if I had a constant fuel source to continue accelerating at that rate, that would be an excellent way for me to simulate gravity. But there is another way to experience a constant acceleration, one that would not require us to constantly be using fuel. And it's a topic that we learned about very recently that I told you we would be circling back to. Imagine a space station that is shaped like a big circle, and you and I and two other people are standing on different parts of it, and we're just out in space somewhere between planets. We would feel weightless, just like the astronauts on the ISS currently feel. But if we could start it spinning, once it's spinning, we would be experiencing an acceleration equal to v squared over r, where v is how fast you or I, our two compatriots, are moving tangentially. R is how far we are from the center of this circle. The idea for this has been around for over 100 years. We've just never built one. It has been shown in many movies and TV shows that want to be realistic about space. Most notably in 1969, a movie called 2001: A Space Odyssey. In that same movie, a smaller ring station is shown as part of a ship on a long trip. So the spinning station would be experienced like this from the inside. As the wheel spins, it says here, you are thrown outwards. Much like clothes in the washing machine on spin cycle. A spinning part of a larger ship has more recently been shown in The Martian, where the non-spinning axis of the ship is where people would experience weightlessness. And the spinning part is where people would experience simulated gravity. So we see here the astronaut is experiencing weightlessness because his part of the station is not spinning. And over there we see another astronaut who's experiencing gravity simulated because that part of the station is spinning. So the simulated gravity that that astronaut is experiencing is equal to v squared over r. This is also shown here in Elysium, which is a movie I've never seen, but in this one, the ring is huge, and so you are able to accommodate entire towns and farms and things like that. Another smaller ship with the spinning effect is in the movie Interstellar. In this one, it's not a complete continuous ring, but a series of pods attached to one another, and you would still get the same effect. I want to note the reason we're talking about this is that although these are all fiction, there are people who really want to build these rings. The limiting factor is the exorbitant cost, much more than can I make the physics work. And there are some excellent supplemental videos explaining some more of the details about how fast you would want the ring to spin and why, that I will again leave in our notes for you to supplement the knowledge that you have. For now, the type of question you might get asked is something like this. A rotating space station is said to create artificial gravity. It's a term I would prefer we don't use mostly. Simulated gravity is a much better way to describe what's happening here. The question is, if the space station that we are going to use to simulate gravity is shaped like the one shown here and is 200 meters in diameter, what angular frequency would produce an artificial gravity of 9.8 meters per second at the rim of the wheel? In class, I will ask you whether or not you were able to determine an answer for this, so please try to bring that answer to class. I want to emphasize this is sometimes called a von Braun ring, and a lot of thought and planning has gone into how big these should be for extended living and what is needed to have on one of these. It's not just fantasy, it's true science fiction.
The men stand with their heads towards the hub. The wheel is divided into 9 sections. The first section is headquarters and communications. The next section will be for Earth weather observation and prediction. Military reconnaissance experts, aided by powerful optical and radar telescopes, will observe every point on the globe as the space station makes its complete trip around the Earth every 2 hours. Next is the emergency hospital section. And then the astronomy division, where men will keep an eye on the rocket ship as it makes its trip around the moon.
I promise I'm not just looking for clout, but drop me a line in the comments to this video if you know another movie or TV show that makes a reference to a simulated gravity like the ones that I have shown here. To end this video, I would like to show you a reminder that people currently do live in space for months at a time on the International Space Station, but because they experience weightlessness the entire time, they have to spend hours per day doing prescribed exercises to minimize and not quite stop the adverse effects of weightlessness.